Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to Advanced Pumping Functions, sponsored by LS Electric. Our presenter today is Stephen R. Peterson. Stephen has been manager of the technical department for LS Electric since 2016. Before that, he handled technical training, support, and repair for Yaskawa Electric America. Stephen holds a degree in electrical engineering from DeVry, and he has more than 18 years of VFD and control experience. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session. And please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Stephen.
Great. Thank you, Amy. Hey, everybody. Thanks for coming in today, this morning or afternoon, depending where you're at. So today we're going to be talking about advanced pumping functions. And specifically, we're going to be talking about the functions that are built into the H100 Plus drive. So for those of you guys that may have listened to our previous webinar, some of this is going to be a review. But what we're really doing is we're stacking on some advanced features that we didn't talk about last time. So we're going to start off with the company overview, mention the H100 Plus and some of the key specs that you'll probably be concerned about and want to know. Then we're also going to do a little short review of PID. I know that was beneficial to a lot of people that were on this last webinar. We're going to discuss the macro, and then the bulk of this webinar we're going to spend on the advanced function setup. And when I say advanced functions, we're talking about things that you're going to stack atop your standard PI loop. So we're going to talk about lead lag control. The majority of this is actually lead lag control and what features and benefits you could get out of it. We do have a short demo video that shows the setup and operation of lead lag, kind of shows how easy it is. We have a PI auxiliary mention for suction control and level control. And we're also going to talk about differential level detection as well as flow monitoring. So for those of you who have not heard of LS, we kind of like to say we're the biggest company you never heard of. So we're a spin-off of LG. So everybody's heard of LG, whether you have a TV or a dishwasher, refrigerator, something. They make a lot of commercial products like that. So we're a spin-off of that, and we're LS, and within that LS group, we are LS Electric. So we are celebrating our 50th anniversary. We've been around since 1974. The LS group in itself is 25,000 employees, and then the LS Electric group is about 4,300, and we are LS Electric America here in the U.S. So we are a South Korean company. So all of the VFDs are actually manufactured in South Korea, and then we ship them over here, where we have a few stocking locations, which will come up on another map. This is our headquarters in Korea. So this is kind of the global map, and on the right there you can see the U.S. So we have a few office locations. I'm out of our Vernon Hills office, which is a suburb of Chicago. We also have another office we recently opened up in Bastrop, Texas. And then we have a third office, which all these do have warehouses as well, which is on the West Coast in Irvine, California. So that's kind of our footprint in the U.S. currently. And so here's the important stuff, and this is the H100 Plus VFD. So this might be a review for some of you guys, but the H100 Plus is the drive we typically push whenever we're talking about pumping applications. So this is our pump drive, and it has the most pump features out of any of our offerings for VFDs. So that's what we're going to be focusing on today. The H100 Plus has all the features that we're going to be diving into. Some of the key specs are it does have an HOA keypad, it does have a real-time clock, and it does have advanced pumping features such as pump clean, broken pipe detection, which is great for irrigation systems, a soft fill operation, also great for irrigation systems. We have a high and low feedback detection, so that's some stuff we talked about in the last webinar. And what we're going to be talking about today is a lot of lead lag stuff, or commonly called multiplexing. These drives do have a built-in EMC filter, and they actually are dual rated too. So most pumping applications we run as a normal duty variable torque application with 110% overload. you could actually flip a parameter and you could get 150% overload out of these drives. As far as capacity ranges, we have a few different flavors of voltages. We have a 200 volt class, which is good for 200 to 240 volt. That goes up to 125 horsepower. So that's in red because that's a new offering. We stopped at 25 horsepower prior, and we've recently expanded up to 125 horsepower. 400 volt, so that's good for 480 volts. We go up to 800 horsepower. And another new release is we expanded the capacity to go up to 600 volts. So 575, 600 volt, we'll go from 7.5 horsepower up to 125 horsepower. And typically all these drives are in stock in our U.S. warehouses that I showed you on that previous slide. This is a standard V/F drive, but it does have some more advanced control methods. There's a slip compensation mode, and there's also a permanent magnet motor control. So I have started seeing some more applications where people are running permanent magnet motors from the output of the drive, and we could actually do that on the H100 Plus. That's a standard feature there. So looking on the right here, this is kind of all just the certification. So it is a UL certified drive. It does meet the new UL 61800-5-1. We do have plenum ratings. All the printed circuit boards are conformal coded to the 3C2 standard. And this last one right here is kind of just showing the communication methods. So some of these are HVAC because we do use this drive in HVAC applications, so BACnet, Metasys, LawnWorks, stuff like that. You could get those on the H100 Plus. Some are built in, some are option cards. For those of you guys on this webinar, you may run into Modbus and you may run into Ethernet IP. So Modbus RTU, the serial Modbus, that's the native protocol on all of our drives. Same thing on this H100 Plus. Otherwise, you could opt to install a Ethernet IP card, and that's actually a 3-in-1 card that could do BACnet IP, Ethernet IP, or Modbus TCP. So you could do any of those protocols with that option card. And that's just a field-installed accessory. Another kind of accessory or option that we offer for the H100 Plus is this disconnect option here. So this is a drive with a disconnect box connected to it. It's a field-installed accessory. And if you open up this box, we do make circuit breakers, we make manual motor starters and disconnects. You could open up that box and it's going to be an LS part in there too. So the good thing is if you ever purchase any of these parts and you open them up, you're going to find that there's more LS components inside. So you're reaching out to us with any help, we could help you on that. We're pretty knowledgeable in it. And then this gives you a NEMA 1 rating as well. So something I may have glazed over is these are IP20. You could get an option conduit kit that screws into the bottom, 2 screws. We do that all the way up to 800 horsepower, and you could mount this on a wall with a NEMA 1 rating. So that's kind of a crash course on the H100 Plus drive. All right. So this is kind of a important thing is when you first power up a VFD, or at least the H100 Plus, is we try to make it as easy as possible. So the drive pops up, do you want to do an easy set? Most of the time people hit yes because they want it easy. The first question it's going to ask you is what is your application? Please select a macro. And I will say that probably 80% of the time people select basic. So basic means follow a direct speed command, follow like a keypad start or some kind of call signal to get it going. That's just a basic macro. Secondly, and then we talked about this last time, it was pressure control. So I have a few slides that pop up that show what pressure control is. So pressure control is essentially a PID loop. So you're going to control the speed of the motor and the pump based on the feedback device. So whether you have a pressure feedback device like a transducer or some kind of flow sensor or like even a temperature sensor, we could utilize that and a set point to control the motor speed. And when you select these macros, what the macro does is it sets up a bunch of parameters for you, and then it gives you a list in order of what you should set up to kind of get your application going. So it makes things a lot easier. So we'll spend a little bit of time showing you that. And then also we do have the lead lag control macro, and that'll be the majority of this webinar. I'm going to show you guys how to set up a lead lag setup, and that's actually in the demo video that'll be coming up shortly, and kind of how it all works, and you can totally customize it. Okay, so everything is kind of based on macros on this drive. Makes it easy. All right, so here we have just like an explanation of PID loop. So a lot of people kind of throw around, oh, I need a PID loop. So first off, what is PID? Well, that stands for proportional, integral, and derivative, so P, I, and D. So it's actually just a mathematical process loop. It's comparing a set point, so commonly called a reference, to a feedback value, and we're going to try to match the feedback to the set point, and to do that, we control the motor and pump speed. Okay, so a lot of times in pumping, people just call it a PI loop because they're not using the derivative. So it's really just a PI loop. You know, you can stare at this diagram on the right here and see that there is a proportional gain and integral time, and there's a derivative in there that you could adjust. Most of the time, people only adjust the P gain and then the I time. Okay, so that's just basic PI tuning right there. So what I highlighted here is the inputs. So we have our PI reference on the top, and then we have our PI feedback. So you're pretty much running this through a comparator, and you're calculating the error, and you're trying to eliminate that error to match the feedback to the reference. So the less error, the more precise your loop is going to be, and the better operation, and the better you can control your process. So most of the time, guys, they're just doing like a PSI pressure control. Set your pressure at 60 PSI, and then ramp your pump up to 60 PSI, and then slow down when we go over, and kind of, you know, throttle it as we need to. So this next slide here kind of shows the macro. So again, when you first power up one of these H100 Plus drives, it's going to say, what's your macro? If you go ahead and select pressure control, it's going to set up the parameters to enable your PID loop. So it kind of saves you 10 steps just by selecting one parameter. So it makes it nice and easy for you. And then what you're going to do is you're going to go into this macro group, and you're just going to review the parameters, and you're going to set them up. So you could see like some of the ones I highlighted here or boxed out are, where's your feedback source coming from? So most of the time you're going to be running a 4 to 20 milliamp transmitter. So just like we're showing you here, a 4 to 20 milliamp output from a pressure transducer. So you're going to tell the drive to look at that. You're going to go ahead and you're going to pop in like a set point, whether it's 60, 70, 80, whatever PSI you may need. That's what you're trying to achieve. And then you do your scaling. So this is all in one list. You go down and you program in your scaling. So in this example, it's a 100 PSI transducer. That's your maximum level. And after you do that, you pretty much hit the go button. You toss your drive in auto, and you make sure you have a run command, and then the drive's going to start regulating pressure. So it really is as easy as that. This is kind of showing where you would set your set point. So this is actually an example of a little demo we have set up in our office here. So we have a 30 PSI set point. Our feedback is 31 PSI, and you could actually see that we're comparing this to a mechanical gauge, which I always recommend to people when they're doing a startup and they're trying to troubleshoot is they say, oh, it's not working right. I'll say, all right, well, let's compare the drive's feedback that the drive's seeing electronically versus a mechanical gauge and make sure they match. That way you can tell if the drive is set up correct or if there's, you know, some other thing going on that, you know, we're not aware of. So it's just kind of basic troubleshooting and stuff. But yeah, it's very easy to set up a PID loop on these. And kind of going forward, we're going to talk about all the things that you could, you know, stack atop these PID parameters. So something new I kind of wanted to add in here because we're going to be talking about some advanced features is inverse PID, okay? So you can say inverse PID is exactly as it sounds. It's the opposite of a regular PID loop. So if you think of a pressure control loop, you're speeding up to maintain a pressure, right? So if you're at 50 PSI on your feedback and your set point is 60, you need to make up that 10 PSI difference. So the motor is going to spin faster. It's going to pump more to get up to pressure. An inverse PID loop is essentially the opposite of that. So your set point is maintained by speeding up a motor to keep the feedback down, okay? So you could commonly look at like a pump down situation, or you could also like look at level control applications or even cooling towers when you're running temperature control. So if you have like a fill pipe that's filling up a tank and you want to prevent it from going over, let's say 10 feet, you're going to need to run the pump faster to maintain that level down to 10 feet. So everything works a little bit opposite. So like on a standard PID loop, you have like a wake up level, you have a set point, and you have your sleep level, and the sleep level and the wake up level are going to be opposite. So your wake up level would be below your set point, and then your sleep level would be above. But if you look on this picture here of like a tank, you'll see that your wake up level is now above the set point. So if your tank gets too high above your set point, that wakes up your pump, wakes up your drive, and you start running until you get down to your set point, and then you start regulating from there. And then your sleep level is actually below your set point physically, right? So that's going to be a lower level in your tank. So why I'm mentioning this is because some of these next set of functions that we're going to be talking about, whether you're running a normal PI loop or if you're running an inverse PI loop, it does kind of change how some of those functions work. So you will see mention of that in the upcoming slides. All right, so this is kind of the bulk of what we're going to be talking about, which is lead lag control. And I mentioned that it is part of the easy set because the first thing you see when you power up the drive is going to be do an easy set. Do you want to do a macro? One of those options for the macro is the lead lag. So it really doesn't get easier than selecting the lead lag macro and getting this set up. So you'll see that in the video. I do show you how it's all set up. It's just one parameter to select the macro. So what lead lag is it's a fully redundant multiple pump control system. And it's possible by using multiple VFDs that are all set up for the lead lag function. In our case, we use the macro. And the main benefit of this is you can maximize the motor and pump lifespan and mitigate pump wear, and you don't need any external devices. Really, the only thing you need is a couple of wires between the drives and at least one feedback device. And we're going to dive into these bullet points right here, but you could customize the stage in and stage out levels. You could also set up the feedback to come from one drive. You could have a separate feedback device on each drive, so you could scale it however you'd like. You could also run different methods for alternation. You could do alternation of the pumps based on first in, first out, first in, last out, or the number of stops to kind of keep all pumps running evenly and not just one coming on all the time. And similarly, you could do a jockey pump operation, so you could have a few larger pumps and then a third pump that's like a smaller capacity just to maintain pressure, so that one takes priority. And we also have data share capabilities, so I'll show you what that is in just a second. So as I mentioned, the lead lag is super easy to set up. When you first power up, it's going to ask what the macro is, and you could always go back and you could set up that macro and you could change it at any point in time. This is the CNF43, that's the actual code on the keypad to get to the macro. So you could set that up there, and then once you select the macro, the drive's going to be primarily 90% set up for you after you select the macro. And the first thing you need to do is you need to go ahead and set up a unique communication address. And that's what this picture on the right side of the slide is showing you is parameter number 1 there is what's your node address on the network. So what we're doing is we're running Modbus from one drive to another. So each drive needs a unique address 1, address 2, address 3. We could do this all the way up to 8 VFDs, but they each need to have their own unique address. If you don't do that, the system's not going to work very well. You may get like COM errors and stuff like that. So after you go ahead and set up that, it's good practice in general whenever you do communication stuff to go ahead and cycle power. So cycle power, make sure there's no COM errors, and then the drives should be able to communicate, after that. And you can continue on and you could go through the lead lag parameters. So I show you that in an upcoming video, what the key parameters are. But before we get to that, this is the macro list right here. So most of the parameters that you need are going to be in this macro list. And so there's multiple columns here. So this is the macro code number, and there is an associated parameter with it that you can manually go to. This is just the parameter name, the default setting, and what the range is and stuff like that. And the key thing I want to mention here is there's this data share, which I kind of mentioned once. And data share means if you program a parameter from one drive, as long as that's the master drive, it'll write parameters to the other drives. So I think in my video you'll see that I changed the acceleration time, and it writes the same acceleration time to all the drives. So it's very beneficial, you know, to kind of make setup really easy and quick. So you'll see that. All right, so after you go ahead and you do your macro setup, some of the key things you'll probably want to adjust is your stage in and your stage out modes. So some people call this like staging and destaging. So there's actually 4 different options that you could select from for how you want to stage in and how you want to stage out, stage and destage. The easiest and most simple and probably the most common is just output frequency. So if the first drive can't keep up pressure, so it's going to be running full 60 hertz to build up pressure and meet demand, run 60 hertz for X amount of time, well then it's going to pull on a lag pump. It's going to stage a secondary pump. So that's the easiest way you could do it, just one thing we're looking at, output frequency. You could also do it based on feedback. So if there's a certain feedback differential between your set point and your feedback, you could use that to stage in or stage out a device. Or you could do both. So you could do it based on feedback and frequency. So if we have a high frequency and a large pressure differential between the set point and feedback, we could use that to stage on more pumps. And lastly, not too many people use this, but it is an option. You could do it just based on flow. So you can run flow meters directly to these VFDs, and you could use that to stage in or stage out. So low flow, high flow, stage in, stage out. Okay. So on the right here, you can kind of see, or the bottom right, there's pump 1 that's running, and I think this one is based only on frequency. So you can see that when the output frequency rises above the predetermined staging level for a set time, so that's how these parameters work. There's a level and there's a time. So if you will go above a certain frequency for a set time, then we're going to trigger the lag pump to come on. So pump 1 is running, it can't keep up, pump 2 kicks on. So it's really as simple as that, and there's multiple parameters you could use to customize this for your system. So this one here is showing the second one, actually I think it was the third one on the list, which is feedback and output frequency. So now we're looking at 2 different things. So we're looking at the frequency of the motor and then also the feedback. So you can see right here that step 1 is look at the output frequency, and the output frequency goes above the predetermined level for the delay time. And number 2 over here on the right is the pressure or feedback deviation criteria is met. So if those 2 conditions are met, then we stage on pump 2. So you're looking at more stuff. So that's an option as well. And just as we mentioned right here is staging out, that works just like staging in, but obviously it's the opposite, and it actually does have its own programmable levels and modes. So you could have like stage in based on frequency, you could have stage out based on feedback. It's all customizable for whatever your needs may be. So there's a lot of parameters that you could put in there. So this is a new feature. So some of these features are, you know, brand new, just coming out or came out within this past month. We did a little bit of a firmware update. We did add a high and low feedback quick destage. So when I say destage, again, it's the same thing as staging out. So what this is doing is it's a function that's going to quickly destage a lag pump to reduce pressure if there's like a sudden, you know, abnormally high or low, depending on what's going on, condition that's met. So remember a few slides ago, hopefully you can remember, it wasn't that long ago, but high feedback destage is valid when you're running a normal PID, which is probably 90% of the time. But if you guys are ever running into an inverse PID, so if you're running like a tank and a level control or something like that, well then we're looking at the low feedback level to D-stage. Okay, so if your feedback goes low, it kicks out the lag pump. Otherwise, if you see a high feedback, so like a sudden increase in pressure, so if you look at this example down here, the pressure goes above the high feedback, quick D-stage level for just 2 seconds, so it's typically a very short time, then it's going to reduce that number of lag pumps, very quickly. So it's a way to just prevent from over-pressurizing the system, okay? So if you have like a tight system, or maybe your pumps are maybe too large or something like that, it could be too aggressive when that lag pump comes on. This is a way to quickly kind of kick it out of the system so you don't over-pressurize. So this is a new feature that you would stack on top of the lead lag. And this is another one, which is the set point modifier. And exactly as it sounds, it modifies the set point. So there's actually 2 different modes here. And the main intention here is that you have your set point, so let's say it's 60 psi, and what it's going to do is it's going to compensate that set point. It'll probably like add to compensate for like a pressure loss within like the pumping system, or the length of the pipe, depending on how many pumps are coming onto the system. So as I mentioned, there's kind of 2 different modes. There's set point modifier based on number of pumps, and then there's based on each pump. Okay. So it might be kind of hard to see this little drawing here and wrap your head around it. So I put a little explanation here, which is the number of pump mode, which is this top line here on this timetable. This uses one compensation value, and it kind of multiplies it based on the number of lag pumps you have. So if you really squint, you can see that your set point is here, and then when you add an auxiliary drive or a lag drive, it's going to add that value times 1. So you could say, all right, increase the set point by 5 psi when we have 2 drives running. And then when you add another one, it's going to add it again, and it's going to add it again. So it's kind of like a multiplier. Okay, so it's multiplying by how many lag pumps you have. And then this each pump one is this utilizes individual values, so a value for each lag pump, and it adds them together. So this, you're not multiplying by the same value every time, it's adding based on whatever you pre-program. So there's add this value, add this and this, add this and this and this, and then same thing when it's destaging. Subtract this, subtract this, subtract this. So we have had some requests, for certain applications, to program this. So that is now a standard feature. As is this. This is stabilization related. So you could have some issues when you're staging and destaging. You're staging on or staging off some lag pumps. So these functions here are kind of meant to stabilize the system to keep operations smooth. And as you guys probably know, and that's to keep pressure, at as close to set point as possible, keep your feedback within check. So the key advantage of stabilizing that system is to also prevent frequent staging and destaging. Because if your feedback is fluctuating around, well, that's going to probably pull on a drive or drop out a drive. So we want to kind of mitigate that, kind of short cycling. So the ways we could do that, these are the new functions that are added. We have a lag fixed speed delay time. And what this does is this keeps the lag pump at a fixed speed for a certain time. So it's kind of like, hey, as it's coming on, run at this speed for this time until that time expires. We also have a lag decel time. This is kind of a special deceleration time when you're running in lag operation. And then we also have a lag decel active time, which is kind of related to this. This is the time at which the above decel time is active for. So again, totally customizable. And then we also have a stabilization time. And what this does is this actually ignores sleep. So what sleep is if you ever meet demand, you could shut the drive off and go to sleep until it's told to wake up. So stabilization time ignores sleep. It ignores a set point timeout, so if you can't maintain your set point. And it also ignores no flow control. So some of those conditions could, put the drive to sleep. It could stop it. So the stabilization time kind of ignores that stuff and says keep running until, you hit your determined time that you program in there. So. All right, so I think a couple more slides, and then I'll show you guys a demo here. So these are specific protection features built into the lead lag functionality. So again, lead lag can be customized, in many different ways, including, with protection features and stuff. So this ensures redundancy and correct operation. One of the things is interlocking. So interlocking, there actually is a little interlock on each one of these drives here. That's kind of a way just to make the drive available or unavailable. So it's kind of like an enable or disable. So if you imagine you have like a triplex system, 3 drives, and you don't want the 3rd drive to run for some reason, you could use an interlock and just open that interlock, and then that drive's not available anymore. It's essentially, it's on the network, but it's not available, and then the other 2 drives are just going to keep running, keep alternating. They're going to keep working off of each other. So interlocking is a very simple but effective kind of feature to utilize. Additionally, there's pump-specific system faults that we've added. So you could enable it so as if one of the drives gets like a lost feedback, it shuts off all the drives. Same thing for a high and low feedback, assuming all the drives are on the same system. Well, if the one drive trips out on high feedback, you'd probably want the other drives to trip out too, because that's a system-wide fault. So that's another thing you can enable on these. Related to communication, so between each one of these drives, there's 2-wire Modbus that, kind of does the heavy lifting of the lead lag setup. You could enable or disable if you want all the drives to trip out if there's a communication error. So you lose communication, something gets programmed wrong, and you get a comm error. You could decide, do you want all the drives to stop, or do you want it to be redundant and just kind of continue on without the other drive that's not working? So again, that's customizable. And then we also have a hand override. So even though you are running a lead lag, you still do have the capability to run these guys in hand. So hand is just kind of like a temporary, way to build pressure. You press the hand key, it's the green button on the keypad, and you could adjust your speed to whatever you need to kind of get by while you're troubleshooting or figuring out what else may be going on. All right, so the last thing I'll mention about lead lag is where is it applied? So firsthand, I've helped out with a lot of lead lag setups. We've had this lead lag capability for quite some time. The more people that learn about it, the more people end up using it because, again, you don't need a PLC. It's all built into the drive's firmware. So we commonly do these on booster pumps, high-rise buildings, taking city pressure and then boosting it up, multiple floors. Critical pumping systems where you need redundancy. We can't have this drive go down. We need another one as a backup. We do those all the time. Applications with jockey pumps, we also use it. And then any location really without a PLC or a SCADA. So, you're in a small building or a residential building or an apartment complex. A lot of times those smaller locations, they don't have SCADA systems. They don't have PLCs, nor do they want them. The nice thing with these is, you just wire up the drives, you select the macro, and then the function, does it all automatically based on what you program into it. So you don't need any external equipment. Okay, so here's that demo I was alluding to. So I'm going to go ahead and this is about like a 5-minute video that kind of shows the setup and operation of lead lag. So I'll let you guys check out this.
This is a short video that shows the setup of lead lag. So in this case we have 2 H100 pluses. So this is a duplex system. There's a 2-wire connection connected to the control terminals, S plus, S minus from this drive to S plus, S minus on this drive. And over here out of the shot I have a single 4 to 20 current generator to simulate a pressure transducer. So how you set up lead lag is the easiest way is to use the macro. So you hit the mode key to get to CNF, which is configuration, and you would go down to the macro selection, which is 43. And you can see this one I actually set to lead lag already. This is actually the first thing you'll see when you start up a new H100 Plus drive. Is the first question is going to say easy set. You select yes, and it's going to say, what's your macro? So in this case, we're using the lead lag macro. The other options are basic, pressure control, which is PID, and we're on the bottom one right now, which is lead lag. So this drive is the same. Another way you could tell that it's set up is if you press your mode key. This is your parameter mode, press mode again. This is user macro mode, UNM macro 2. So this is the lead lag macro. So I'm going to go to that on this drive. So you can see it says the same thing, UNM MC2, so it's the same macro. So I really didn't do much programming on these. I enabled the macro, which sets up most of the programming for you. And the first thing you need to do when you're doing lead lag is set up the node ID, which is the Modbus address. So you can see this one is set for address 1. This one is set for address 2. So that's the most important step of lead lag. Otherwise you'll get COM errors. You'll probably get some unexpected operation. And you can see that the other things that the macro does is it enables PID. It sets lead lag selection to be a fixed lag. So you could put a preset speed for the lag whenever it comes onto the system. Some of the stuff that we're talking about as well is like a first in, last out. This is adjustable. We default to a 24-hour alternation time, and you can see that time count up as it is operating. I'm going to go ahead and adjust some of these parameters. So the number of pumps is going to be 2. Okay. And then it automatically takes down the number of drives. I'm going to do the same on this one. So some of these parameters are data share. So if you look at the table, whatever drive is the master drive, so you'll see like a plus on the top of the screen when you're in an auto mode. If you program from that drive in the macro list, it's going to automatically send that parameter setting to the other drive. So that's advantageous to make setup a little bit easier. So actually this drive is the lead drive, so I believe Excel time might be one that does like a share. Yeah, so I changed this to 10. It automatically adjusted that one to 10. Just to show that again, I'm going to set my decel time to 10. Now I can see that that's at 10. So it wrote from one drive to another, so it shortens up your startup. And the only other thing I did off camera is I did go and set up a set point of these to 60 psi. That's another kind of important thing, is to make sure that your set point is typically the same. So this drive right here is the drive that has the feedback connected to it, and this drive here has no feedback connected to it. So if you go into that macro and you scroll down until you see the feedback source, the feedback source is set for network, so it's getting the feedback from the network. So we go back to our main screen, we could see our set point, our feedback, and our amperage. So I'm just going to adjust my little current generator here, and you can see that the feedback is shared over the network. So less wiring, it's all done over Modbus. Okay. I'm going to show you the staging pressure deviation is 5 psi. So that's 5 psi from your set point. Your staging delay time is 5 seconds. So if we can't maintain within 5 psi of the set point for 5 seconds, it's going to stage the lag drive. Lag frequency is set for 60 hertz. Destaging is 5 psi in 5 seconds. There's also the staging frequency. So remember, you could set it up to be frequency and feedback. So if the first drive is running 60 hertz full speed and you have a 5 psi delta, it's going to start up this one. So yeah, right now I think this one should start now that I put in the run command. So it should see that this one is at full speed. Yep, and the pressure is low. So this secondary one came on. And I'm going to increase the pressure to show the D stage. So again, we're just simulating a pressure increase with this 4 to 20 generator. Alright, so now we can see that the lag drive is staging out. Alright, so the last thing I'm going to show you is, so this one is running 60 hertz. I'm going to shut off that drive. and you see that this one is running now, and it's ramping up to speed, and it's actually the master drive, and it's the lead drive now. So it's fully redundant. If this drive tripped out or there's any issue, and same thing for this one, you would see the other drive automatically take over for that.
All right. Yes, hopefully you guys found that video useful. I tried to demonstrate all the functions and stuff in a short amount of time, at least the key functions. And one of the big things is the redundancy is if one drive's running and it shuts down, whether it's a trip or somebody shuts off a disconnect or something like that, the secondary drive, which might not be running at the time, sees that, and then it kicks on. We've used this many times, and it works very, very well, and people love the redundancy. It just works. So now we're going to kind of switch over and talk about some other functions. So we're done with lead lag. I see there's some questions. We'll get to the end of the webinar, and we'll answer those questions related to lead lag, but great questions so far. Let's talk about some of the operations we could run when we have two transducers or dual feedback. So for that, we call that PI auxiliary because you have an auxiliary transducer. So a lot of times you may have a pressure transducer and then a secondary transducer, such as a suction, side transducer, a water level sensor, ultrasonic sensor, whatever you may have, or a float, or you're running like a vacuum control loop. So we could do dual feedback monitoring, and this is built into the H100 Plus, so we can monitor suction pressure, for example, at the inlet, and then control the output frequency based on suction and pressure feedback. So we have a kind of picture on the bottom here. So if we look at the suction control, so you have two transducers, one on the inlet, one on the outlet, and again, we're only controlling one pump, one motor. So it's like, well, how do we control the speed when we're monitoring two different things? Well, this is kind of how it works, is when you're running an auxiliary PI loop, you're always monitoring both, but you're only using one to control. So for example, if your PI auxiliary set point, so like if your suction level is greater than or equal to the sleep level that you programmed in there, well then we're going to look at that auxiliary PID loop to change the output speed. So if you have like low suction, suction takes priority over pressure, okay? And then if you meet the sleep level for your suction, well then we control pressure feedback. So another way you could kind of think of it is like a water level control. Like if you're running a submersible well and that water table goes low, well then if you get a really low water level in there, then we switch over from pressure control to water level control. So we say, let's wait until the water table rises, let's wait till the level goes up, and then once it does, okay, then we could run our pressure control loop again. So the drive kind of switches between those two feedbacks, and it's always monitoring both of them, but it's only using one of them to control it. And it'd be a similar situation on the vacuum control. So the only thing really you're adding here is an extra feedback device, and we could go ahead and use these functions. Similarly, dual feedback stuff, we could do a differential level control. So if anybody's ever running something where you have two transducers, one before a filter, one after a filter, that's advantageous because you could use that to detect if there's some buildup, some clog in the filter. If there's a big enough of a pressure differential, we could actually trigger a digital output on the drive to run a backflush operation. So that's kind of what we're showing you here, is we're monitoring those two feedbacks, measuring the difference between the two, and the drive actually does have a backflush functionality built into it. And you could actually program an output, and you could have the drive pop up with like a warning or a trip of kind of what's going on there. So this is another capability. And let's see, I think we're coming on like the last few functions here, with one of them being flow monitoring and control. So we could control the drive based on flow. It seems like more people are just monitoring flow. A lot of these larger pumping systems, I feel like I get a lot of calls from people out west that are, just big horsepower and just pumping off of rivers and stuff. A lot of times there's regulations and there's limitations on, how much water you could pump out of a reservoir on a given day and a given time. So we could actually monitor that with a flow meter, and you could shut the drive down. Say, hey, pump 10,000 gallons a day, and then shut off until tomorrow. So if you're ever kind of pumping off of some kind of public water source, this may be useful. Other things you could do with the flow meter. First off, you could just simply display the flow rate of the flow meter. So you could use it just for monitoring only. We could run either a pulse train input, so that's a digital signal to the drive's input, or you could run an analog signal, like a 0 to 10 or a 4 to 20. We could trigger an output, so if you want to know, hey, when I hit my target, flow rate, I want to trip out, I want to close the contact, I want to alert something, I want to do something, that could be programmed into the drive. Additionally, we do calculate or add up, the accumulation of the total flow. So this is a total accumulation, which you could reset. As I mentioned, you could trigger an output to do that as well. And you could also use flow to put the drive to sleep. So you could monitor if there's a low flow situation or even if there's a no flow situation, and you could say, hey, something's wrong with the flow, let's shut down. So that's number 5 on this list here. And then kind of the first thing I mentioned is you could have a high or a low flow limit on there, and that would also work with your PI loop, and it would reduce the output speed of the motor and the pump based on flow. So there's a lot of things you could do just by wiring up a flow meter directly to the drive. All right. So these are features we did not talk about, and there's a lot of them, but we're short on time. So I'm just going to mention them real quick. So things we could do is we could do no flow control. We could do that without a flow meter. So we have a way of detecting that as a built-in feature of the PID loop. We could also do pump over cycling protection to prevent short cycling. We have a low and high feedback detection. Those are 2 separate levels, 2 separate variables. We could do a set point timeout, which the drive can't maintain the set point. We could shut it down if something's wrong. We could do a high current limit, so we could limit that current and it'll throttle down the speed or fold back the speed when amperage goes high. We do have a backspin timer, which is great for vertical turbines where the water column would fall down and backspin the motor. We could delay the run so we don't damage anything. We do have a minimum pump speed. That's a super common thing that people use on PI loops, just like a minimum, so you're not going to be running at 10 hertz all day, based on your pump curve. Pump clean operation, common in wastewater where you're rotating back and forth, the anti-jam. We have a soft fill operation, decel valve ramp for check valves. That's a special decel time. The multiple motor control, so that's kind of related to lead lag. We could also do it just with the digital outputs if you don't feel the need to run multiple drives. Pipe break detection, another one for irrigation. Underload detection, like you lose your prime going to the pump, your current drops, you could trip out on an underload detection trip. Thrust mode, great for you guys that are running submersible pumps, and there's actually more on top of that. So you could always find the brochures and product flyers and stuff on our website, which I'll share next, and you could kind of read into it and give us a call, shoot us an email. So I'll show you that. So I know we talked about it a lot, but I just kind of want to, remind you guys that it's really easy. We try to make things as easy as possible for, all of our customers we work with. Most of the parameters that we mentioned are in that easy set menu, which is like a wizard. So the drive asks you what you're going to do, you answer the questions, and you're good to go after that. So you kind of just press your up and down arrows in your macro group, so you don't need to navigate through all 1,000 parameters. You kind of just go in a linear fashion. We also do have quick start guides. This is a little screenshot of our quick start guide for PI setup. That's probably the most common thing we do with these drives all day, every day is PI setup. We have a 2-page document that shows exactly what you need to do. A lot of times we send that to people, we never hear from them again, and that's a good thing because they figured it out. So all that stuff's available on our website, which is just lselectricamerica.com. We also have a solution square, which is a knowledge base. All the answers are there, but you could always feel free to call us. We don't mind talking to you. Additionally, I think the keypad is pretty intuitive. It's customizable on the H100 Plus, but everybody likes touchscreens. This is an LS HMI touchscreen that we offer, and we have a free program that you could load into it, and it shows you your handoff auto keys, it shows you your set point, it shows you your feedback. There's nice little bar graphs and pop-ups and everything like that. It's a fully functional program that replaces your keypad. You could download that for free. All you need to do is purchase the hardware to dump it into. So we have a lot of customers that are kind of going this route because everything's got to be touchscreen nowadays. And let's see. I think I have another slide here. If you do prefer not to set up stuff on a keypad, we do have this DriveView 9 software. It's a free computer-based software. You could dump parameters in, you can make backups, you can make offline modes, you could do copy and paste onto different drives and stuff like that. So that's a free software on our website. And then, where's my next slide? Here we go. We do have YouTube videos that actually show how to set up PID. We do have an H100 Plus overview video. We do have another video that shows lead lag setup. You might be stuck listening to me again because I think I made the video, but it kind of dives a little bit further into it. So we do have a YouTube page. If you can't sit down and read stuff, you could always watch our videos. And this is our support channels. So we do offer an 800 number, so you could always call in for help. We could help you out with whatever you need. We do have a group email, which is shared right here, and I showed you guys our website. So we have multiple ways that you could reach out to us. So that's all I have. So I think we could probably switch it over to questions, Amy.
Sounds great. Well, Stephen, thank you so much for that presentation. In just a moment, we'll begin the Q&A session, but attendees, if you would like a certificate of participation for today's webinar, you can do so by clicking the View Certificate button. And if you've got questions that you haven't sent in yet, now's the time to do so. Keep those questions coming, and we'll keep pulling from the chat and getting them in front of Stephen to get to as many as possible. So at this time, we'll begin the Q&A. One of the questions says, will lead lag pumps alternate, or will there be a fixed lead pump?
Okay, yeah, so it can pretty much be however you want. By the default it's a 24-hour alternation, which is actually what most people are happy with. So if the lead drive is running for 24 hours, after that time it's going to automatically switch over to the other one. So you could always shorten that time, you could extend that time, or you could just kind of disable it so you don't need to alternate at all. So again, it's one parameter and you could kind of customize it for whatever your needs are.
Okay, sounds great. One of the questions says, are there any parameters in the VFD to prevent the lag pump from short cycling?
Yeah, so I think that might have came up in the slide. So we do have some new features that are for like the stabilization related parameters, and they're literally dedicated to prevent the lag pump from short cycling, because sometimes the lag pump comes on and then you hit a higher feedback and then it shuts down. So there's those three functions in there, like the special lag stabilization parameters that should help out on that. So it's good you asked that, because it's a new feature we added. So
sounds good. Another question says, can I back up parameters or copy them to the keypad?
Yeah, that was something I didn't mention, but I did mention the software you could back up parameters. But this drive does have built-in memory into the keypad, so you could set up one drive, do a copy, and then paste it into another drive, and it makes the setup even easier.
Sounds good. Someone said, can you access the VFD remotely?
Yeah, as long as you have it, connected to like a network. I know some of our customers use like those little cellular devices to log into it, and they use that with like a combination of DriveView 9, which is the software. You could log into it, and you could also purchase like an Ethernet card and connect the drive to the internet via that way as well. So I think there's a few ways that people end up doing that. So
Sounds good. Someone asked, what would be the best way to control water level in the cooling tower, in a cooling tower using the PID function?
So the big thing is you would need like a sensor. So the way they detect water level is they'll either do like an ultrasonic sensor at the top, or they'll do like a pressure sensor at the bottom, because water pressure weighs a certain amount with, like, I forget what the formula is for PSI to feet or whatever. So you need that sensor on there, and then you could decide if you're going to do that like as an auxiliary loop, or if you're just going to do like dedicated water level. But it would probably be like an inverse PI setup.
Sounds good. One attendee asked if you could go into a little bit more how the break detection, pipe break detection works.
Break detection. What was that question? There's break detection?
Yeah, it says, can you go into how the pipe break detection works a little more?
Pipe break, okay, yeah. Yeah, so pipe break detection, essentially it looks at, I didn't have it on here, but I always have other slides, somewhere. It looks at speed and feedback. So when your feedback drops, the drive speeds up, right, to build up pressure. So you could kind of set up a time delay. So if your pressure goes below a certain point and your speed goes up to a certain point, we could assume something's wrong. And then you could do like a warning, which means keep running but flash on the keypad, or you could do like a trip where you stop. So yeah, that's how that setting works.
Sounds good. Someone asked if these drives are available in the US and Canada, or US only.
Yep, US and Canada. Yeah.
Sounds good. We've got another question that says, do I have to use PID on the H100 Plus?
No, you don't. Yeah, so you could just use like the basic macro, which is, the basic macro is really just no macro at all. It's kind of like none. A lot of people do that. They just follow a 0 to 10, they follow a 4 to 20, and it's a direct speed control. So you don't have to use PID, but we're kind of talking about it now because if you're not doing the basic macro, most of the time people are doing PID or lead lag or something, like that. So.
Sounds good. Someone asked if lead lag pump control is also good for open loop control.
So I guess it depends on like what you mean, like open loop. When I hear open loop, like some people mean like no feedback. You do need feedback when you're running lead lag, so that's like a requirement. So yeah, in that case, I'm going to say no unless I learn something else about what they're trying to do.
Sounds good. Somebody asked which ratings of the H100 Plus are available in 600V.
Yes, that's 7.5 horsepower up to 125 horsepower. That's the current offering. I think we're going to expand that eventually, but that's the initial offering. That's like one of our newer flavors is the 600 volt. So especially for the person that asked about Canada, you guys may find that voltage useful.
Sounds good. Somebody asked, I believe this was around slide 9, if these need bleeding at all?
I think that'd be more of like a pump specific question. I don't think it really has much to do with the drive. I guess one thing I could relate to it is you could run the drive in hand. So hand is commonly used for checking motor direction, and you could kind of also use that for priming the pump and maybe bleeding out lines as well. So you could always run that hand operation, which is kind of just manual.
Okay, sounds good. All right, everybody. Well, that puts us at time for today, which brings our webinar to a close. If we didn't get to your question, which we didn't because there are a lot of them coming in, and please keep them coming. We'll get them to Stephen and the Ellis Electric team so they can answer those offline. But attendees, you can look for an email from us later today, which will have playback to this presentation. But also feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars, including, of course, the one from Stephen from last year. We'd like to thank Stephen and the Ellis Electric team for today's presentation, and thank you everyone for taking the time to join us today. I hope you all have a great day.
Thank you, Amy, and thanks everybody for attending.